So we are live. Welcome everybody to our next OpenStack online meetup. Today with us is Yves Fauser from VMware. You guys might be already familiar with Yves. He ran a series on OpenStack networking last year in November. We had 3 sessions, which actually was the most successful series we ever did in the OpenStack online meetup, with more than 20,000 hits on YouTube. So we discussed with you for quite a while to have a follow-up session, and here it is. So with that said, let me hand over to Yves. The stage is yours.
Thanks, Raphael. Yeah, so Raphael put the heat on me a little bit with those stats, so I hope I can make justice of that. So let me share my screen first, if I find it. Okay, can we all see that? I guess so. So yeah, Salvatore is also was also planned to join, but I'm not sure if he can join or not. So I'll just take the session myself. If there are any questions, just type them into the IC channel.
Yeah, one thing, just a short interruption. I always forget that at the beginning. So in case you have any questions, we are on hash OpenStack #community. Ask your questions there, or you can also send in questions via Twitter at OpenStack_OM. Okay, I'll mute.
Okay, so let's get started. So from the agenda, I thought I'll do a little bit an update of the sessions that we had last year. So last year we just glazed over some details of Nova networking, and also since last year there had been, I would say, a lot of discussion on Neutron in general, and if Nova networking is not enough for most of the deployments. So I just wanted to do a little bit a refresher on Nova networking versus Neutron, and go specifically into a topic that we didn't address last year, which is the multi-host mode. Then we'll go into some more details of the Neutron plugin, especially on how to integrate services with services plugins, and also we will discuss the ML2 plugin versus Monolithic plugins. This was also something we didn't have in the sessions of last year. We'll go over some plugins and mechanism drivers of ML2 that were added in the Icehouse release. As always, this is an incomplete list. I will give you some more links on where you can find a more complete list. And then we'll do a little bit an outlook to some Juno features that are also related to what we'll discuss first on the multi-host mode, and that is the distributed virtual router, LAS3 high availability, and IPv6 support. Yeah, so let's get started first of all with the Nova networking refresher. So Nova networking was the first network implementation in OpenStack, and in fact it is still there. There was talking about deprecating Nova networking since a long time. However, it's still very much alive, which is partly because of a missing feature, which is the multi-host mode that I will introduce to you, and also since actually a lot of people are still using it in production today, and there is up to date not a really great migration story from going away from Nova networking to Neutron, and that will get better over time, but it is still, as I said, there and is used by people. There is no new features going into it, and it's relatively basic in that it only knows 3 models, which is the flat DHCP, and VLAN-based model. If you want to have more details, we discussed those models in great detail in the first session, so just watch the first session and you'll get more insights into that. What I wanted to go into detail today is the multi-host mode that we didn't discuss last year. So normally in Nova networking, the Nova networking node or the node that holds the Nova networking role, if it's not deployed in a multi-host mode, is first of all a single point of failure. And it is also a choke point, especially for east-west traffic. So for traffic that stays within a data center between VMs or instances of the same tenants and projects. So all the traffic between compute nodes, between instances on compute nodes that are in different layer 3 subnets have to go to this central networking node that then does the routing in between those layer 2 segments or these subnets. And all the north-south traffic needs to go through it. So as you can see, if your environment grows pretty big, this can be a choke point. So what was introduced then was the multi-host mode, and with the multi-host mode, you basically install the Nova networking component on all the compute nodes. So essentially, each compute node is also a networking node. This then means that all the netting, all the routing is done locally at the compute node, and each of those VMs or instances are having a default gateway pointing to the local namespace router on the local compute node. So inherently, this is highly available, because if you lose one compute node, you'll also lose the instances running on it. So you don't really have a problem with the fact that also your router is gone. The thing that is not so great about multi-host mode is that you have an IP address sprawl, because especially if you want to do SNAT, or if you do SNAT, which is done by default if you create a subnet, if you don't say that you actually don't want to do SNAT, then all the compute nodes will need an IP address from the external network to be able to net traffic coming from the instances to the external network. And especially external IP addresses, publicly addressable IP addresses, are a rare good. And if you have like 500 nodes in your OpenStack environment, you would need 500 public IP addresses, which is not something that is easily available for you. Also, you will need one internal IP address in each network that gets created when you create a project. Now, if you put Nova networking and Neutron side by side, you will see there are a lot of good reasons for Neutron, and those good reasons also led to the development of Neutron. So first of all, we have more network implementation options, which is because we have this pluggable architecture that we will speak also later on about, which allows vendors to integrate their own network solution, their own network implementation into OpenStack. So we have a standardized API layer, and below in the plugin, we can have specific mechanisms that drive the underlying network architecture that a vendor provides. So this allowed a lot of options, while in Nova networking, certainly a vendor could patch Nova networking or build its own implementation of Nova networking, but that would not be pluggable, and you would have problems with release cycles and QA and all that stuff. Also, there is more ability to create, to dynamically create networks and virtual routers, load balancers, and VPN under the tenant's control. Instead of having a fixed per project VLAN allocation. So in Nova networking, if you create a project, you'll get a VLAN to put your VMs on. With Neutron, you can dynamically create new layer 2 segments. You can create routers, and that is all under tenant control with an API that is accessible for the tenants to consume those networking services. Now, on the pro side for Nova networking, it's a simpler model. It's easier to understand because it's compute-centric, and you don't have all these complex options, and also you tend not to have too much of this like networking speech in the Neutron concept. So it's easier to grasp what mobile networking does. And for a lot of people, it's those simple models are good enough. If you have an environment where you actually fine with patching all instances, all VMs into a single network or in a per project network, and you don't want to actually create virtual routers on the tenant's control, etc., then mobile networking might still be okay for you. The code base is in a bug fixing mode since a long time, so this means basically less friction, right? The probability to run into bugs is less than with Neutron, where there is a constant development on the code base. Now on the side of HA and scale out, so the multi-host mode, which is, I would say, the key missing feature in Neutron, that where Nova networking has more options than Neutron, that is actually addressed by the distributed virtual router and HA in the Juno timeframe, and we'll speak about that later on. So for more details also on Nova networking versus Neutron, you can also refer to the first and second session of our series of last year. So we talked about the Neutron plugin concept last year already. So the basic idea is we have a set of defined APIs in the core component in the Neutron server, and these core APIs have an abstracted way of defining what a network is. So you just create a network, and what a network actually is in terms of the actual implementation is up to the plugin to decide. So the vendor plugin or the plugin of something like OVS will then map whatever is a network to the actual implementation. This allows for independence in terms of the vendor and in terms of the implementation.
Just a short interruption. If the slides are not moving.
Slides are not moving.
Yep.
Where are we at the moment? We are still on slide 1. That is not good.
Oh, now we're there. Now we're there.
You seeing slide? Which slide are you seeing now?
We're at 7 now.
Okay, that's not good. Okay, so I hope this works now. Wait, let me flip the slide. Do you see the next slide now?
Oh no, we're still actually at.
Okay, let me see if we can fix that. So I'll unshare and share again. Does it look better now? Raphael, can you see the slide now?
Yep, looks good now. Okay, should work. I'll keep you posted if we have any issues with.
So we are at the OpenStack Neutron plugin concept refresher slide. Is that right?
Yep, exactly. That's what we see. Thanks.
Okay, and now let me switch, and the switch hopefully worked.
That worked. Thanks a lot.
Okay, good. So I was just saying we have this pluggable architecture down there, and we also already spoke about the pluggable architecture last year, but what we didn't went into details and is how this plugin could actually be implemented. So first of all, there is a separation of core and services plugin. So the core plugin is implementing core functions of Neutron, things like creation of layer 2 networks, IP address management, and stuff like that. And then you can have services plugin to do advanced functions, things like virtual routers with layer 3 routing, load balancing as service, firewall, VPN, etc. Now, it is up to the vendor or to the plugin implementer to choose if you want to implement relevant extensions in the core plugin itself or in services plugin. So as you can see on this slide, we have certain functions like core layer 3 firewall, and this then map either to the core plugin or to services plugin. And if you look at what this actually looks like in the config file and in passes on the system itself, you can see here the core plugin, as an example, is an ML2 plugin. And here we have a layer 3 router services plugin, and this then maps to the pass to the code base on the file system. Then there is the modular plugin called ML2. So before ML2, if a vendor wanted to develop a plugin, he would need to build a complete plugin, including IP address management, database access, and ID management of the underlying IDs in the network implementation. So one example would be if the underlying implementation uses VLANs, you need some form of VLAN ID management. If the underlying implementation uses VXLAN, you will need some ID space management of VNIs. Now, this, of course, means you have a lot of repeated work for vendors or for the community to implement new plugins, and you have a lot of just copied code. And the ML2 plugin takes the concept of separating those core functions, the ID management, and the actual implementation on calling external APIs or external functions of the vendor's environment of a specific implementation into pieces. So the core ML2 plugin implements database access and all the base work that the plugin needs to do. The type manager and the type drivers are implementing the ID management. So, as an example, VLAN ID management. And then you have the mechanism drivers that are implementation specific. And those mechanism drivers can also be different on different compute nodes. This then enables an environment where, as an example, you could define that a specific network is a VLAN, and no matter if one part of your implementation uses OVS and the other part of your implementation uses Linux Bridge, they will use the same VLAN and be patched to the same network. There's also the idea of doing bridging between technologies, things like VLAN to VXLAN bridging, but that is not implemented yet. So today you'll have to look on how things work together or don't work together if you use the same type but different mechanism drivers. Okay, so also here you can see a slide where you can find the configuration parameters and what this actually means in the pass on the system. So here is an example. We are using two mechanism drivers, Open vSwitch and Linux Bridge, and GRE as the type driver. That's just one example, and that then maps to the location down here where you have all those drivers. Now, what would be a reason to use a monolithic plugin versus a modular plugin, an ML2 mechanism driver? So there might be vendors that want to use a very own integrated IP address management database access or some form of system that doesn't really use the same bits and pieces that the ML2 driver uses. And then it's perfectly fine to build an own monolithic plugin. Also, at the time ML2 emerged, there were already a lot of monolithic plugins out there. So there might be a very stable code base with a stable database access, etc., and vendors might not choose to switch over to an ML2 mechanism driver very soon because of that. So it might take some time to adapt to the ML2 mechanism driver, or you could actually really offer both also. It's really up to the vendor to decide. Now, I guess there is a little misunderstanding in the community of monolithic plugins versus ML2, and sometimes I hear that monolithic plugins are deprecated. Actually, what has been or what is deprecated in favor of mechanism drivers is the existing OVS and Linux Bridge plugin implementations. So up until Icehouse, we were able, or we used the OVS plugin or the Linux Bridge plugin, and now we shall be using the OVS mechanism driver or the Linux Bridge mechanism driver. Now, most of the code base is actually reused, and also agents of, as an example, the OVS implementation are reused in ML2. So it's not that everything has to be relearned. It's, I would tend to say, just this layer that modularizes the plugin a little bit more. Okay, here are some of the plugins and mechanism drivers that we added to the Icehouse release. There is a new mechanism driver for the Open Daylight controller, which is an open source SDN controller. So that could be interesting to get some hands-on and some experiences Open Daylight. And there is a Brocade ML2 driver for VDX switch cluster. Then we also have new Neutron plugins. So New Arch Networks and IBM has brought out a plugin, not a mechanism driver. We have new services plugins, especially on the load balancing as a service side. We saw some vendors develop services plugins, and there is a VPN as a service driver for CSR routers from Cisco. There are also a whole set of other things that were added. So if you want to have more details, you can have a look at the link I put down here that has all the blueprints for Icehouse, and then you can check if it actually got implemented or not. One thing that is working since Icehouse and is actually pretty interesting is also the support to plug in virtual networks into Docker containers. And I remember that this was also shown or mentioned in one of the Docker sessions here on the online meetups. Okay, so now that we have covered the ML2 and also the Nova networking versus Neutron, here's a little bit an outlook into Juno. So first of all, if this would be like a VMware product session, I would put a deep disclaimer on it that everything I show here is like it could happen, but you can't sue me if that doesn't happen. So it's kind of the same here. I guess it will come, and I could see a lot of information about it already. However, it's future, right? So have a look at the links I have in the slides later on, and see how it progresses yourself. But I'm pretty confident that it will come in Juno. So first of all, there is no equivalent of the Nova networking multi-host mode in Neutron today. So as of Icehouse, we don't have that. And the layer 3 agent is a single point of failure. Now, some implementations of vendors like us with VMware NSX already have HA today and distributed routing today. Also, there are some examples in the community on how to use redundancy methods to implement HA on virtual routers. So it's not, we should not say that it is not available today as of Icehouse, but in the OVS and Linux Bridge implementations and in a lot of other implementations, it is not available today. So what we are speaking of here is a distributed router and HA capability for especially the OVS mechanism driver. So yeah, here again, if you want to scale out your capacity for east-west and north-south traffic, you would add additional networking nodes. But these networking nodes, again, would not be highly available if you don't patch it yourself or if you don't develop stuff yourself. And it's not distributed on all the compute nodes as the Nova networking multi-host mode is. So what we will get is we will be able to deploy a network function, network routing function, so the layer 3 agent that drives then namespaces on the compute nodes. And the compute nodes then will implement routing for east-west traffic and for floating IPs. SourceNet will still be done on a centralized node, and this is to avoid the IP address sprawl that we talked about in the Nova networking before. And since then the networking node that does the north-south traffic and the SourceNet is a single point of failure, that of course needs to be addressed, and that is addressed through virtual routers HA that we'll have on the next slide. So we'll have what we call internal routers on the compute nodes, and those internal routers share the logical internal IP address of the centralized network node. So if the VM or instance on the compute node speaks to its default gateway, it will actually speak to its local gateway on its local compute node and not to the remote network node. They will have separate MAC addresses, so it will not be that we'll share the same VoIP address or stuff like that. So it's just listening to the ARPs and then responding with its MAC address. So for east-west traffic, so for VMs or instances that talk to each other over the same logical router, it will then be either kept locally in the compute node if both of these instances are on the same compute node, or it will be sent over the transport network between those compute nodes directly. So if you use tunnels, then obviously it will go over the tunnel to the remote compute node and then to the other VM. So just to make sure that this is clear, VM gray here and VM blue here is in different IP subnets. And if VM gray wants to talk to VM blue and they share the same logical router, we will then send the traffic over this tunnel directly to the other compute node. And if it stays within the same compute node, it will then be routed directly inside of the compute node. For SourceNet traffic, we will send it to the remote centralized network node, and it will then implement the SourceNet for all the instances that use the same network node. So we can still scale out network nodes, but we will use one network node for a logical router to do the source netting for all the networks that are connected to this logical router. And if we use floating IP, then we'll actually implement the floating IP, the netting for the floating IP on the compute node. So for floating IP traffic, it will be sent directly from the compute node to the external network and out to the internet. I go back to this slide. There is a subtle little detail on that slide. This is actually for traffic going back to the VM from the internet or from the wide area network. Traffic going out of the compute node to the SourceNet network node is actually going first to the internal router here and then over the tunnel to the network node. I just didn't want to put like two slides one after each other, and I just decided to explain that verbally. Okay, then we'll also have HA for virtual routers in the Juno timeframe. And the way it's implemented is using keep alive D. And if you create a logical router, or if you create a new router, you will have the option to also have it as an HA router. And then you will have an active and a standby router on two different network nodes. And there will be an HA network created between those two network nodes to exchange state information and to do a heartbeat between those two nodes. They will share virtual IPs. So each of those pairs have their own virtual IPs into the tenant's networks and to the external network. And if we lose one, then the other will take over, and then we'll respin a new standby on another network node. So with the combination of both the distributed virtual router and HA, we are now really on parity in terms of features, and I would say even better because we don't have the same limitations as we had with Nova networking and multi-host mode. So, and also what we had in the past or until now in Neutron is there were a whole set of issues that prevented us from really using IPv6. There were also some examples on how to patch Neutron and Nova to be able to use IPv6 in like some basic functionality. However, there were a lot of, I would say, implementation flaws that were difficult for IPv6, especially the fact that in IPv6 the regular standard way of assigning IPv6 addresses is through stateless auto configuration and router advertisement. And the Neutron or OpenStack networking model actually always expects or always expected that will give the instance an IP address through a DHCP server. So stateless auto configuration in IPv6, what it does is the instance, the OS of the instance assigns an IPv6 address himself using some algorithm like taking into consideration the MAC address of the system and stuff like that, and then comes up with its own IPv6 address combined with the network address that it learns from the router advertisements. And then it shouts out if this address is already taken. If it's not taken, then it assigns itself the IP address. Now, what we'll get in the Juno timeframe is a solution that allows Neutron to guess or to find out what the IPv6 address is by taking into the consideration the same algorithm for IPv6 address or stateless auto configuration than the OS uses. So Neutron will be able to find out what the IPv6 address will be that stateless auto configuration will give, and then we don't have the same problems we had before with security groups and port security that prevented the system or the instance to work correctly. We'll also get DHCP v6 in DNS mask. So for those that want to use DHCP also for IPv6, there are multiple patches that will allow that. And also support for a router advertisement daemon that will advertise the router into the subnet so that stateless auto configuration actually works. The first one, provider networking upstream Slack support, is actually if you use provider networks. So if you patch it directly into a VLAN or into a provider network, there was also support in provider networks for GRE and VXLAN, but usually you use VLANs. And then in this case, you would use an physical router or something that routes you out from this provider VLAN. With router advertisement daemon, we'll get also the ability to use also the virtual router. There has been, or there was a new group was founded to work on all the IPv6 issues that we have in Neutron today. If you want to see more details, you can go to that link. This will point you to the subgroups, working items, and then you can really see on what they are working on and what they do to make IPv6 work in Juno and later. So long story longer, we'll get IPv6 support in Juno. Okay, so there is much more. There is a big number of vendor plugins, of new ones, and mechanism drivers. A lot of also enhancements to make things better, reliable, faster. One thing is an automatic way of detecting dead daemons and restarting them. But yeah, it's a little bit difficult and too early for me to say what will be in and out. So have a look at the blueprints yourself, and yeah, just browse through them, and you will find a lot of interesting stuff. And maybe we'll just do an update in half a year or a year from now, and we'll show you what actually got into Juno or not. Okay, and I'm actually at the questions already, so that was a fast session. Raphael, do we have anything in the chat in terms of?
Yeah, thank you so much for the presentation, Yves. There's actually a couple of questions, so let's walk through those. So the first question: does Juno support distributed routing?
Yeah, that's
routing.
That's the VDR that I just explained in the last couple of slides. That is the project that will introduce VDR or DVR.
Okay. Our L3 plugin, is it different from ML2 plugin?
L3 plugin, is it different from the ML2 plugin? So the ML2 plugin itself uses basically normally uses the virtual router plugin, services plugin that also OVS uses. If I'm not mistaken, there have been some development that I saw in Juno to use the ML2 plugin with a specific mechanism driver to support. No, wait a second. There have been development for services plugin to do routing on hardware gateways and on implementation specifics, like in some fabrics of some vendors. But to my knowledge, we will always use the Layer 3 services plugin, as I showed in the services plugin session, to do the Layer 3 routing, actually, and to implement things like firewall load balancing as a service and things like that. I don't see it as a part of ML2.
Okay.
But it could change, and maybe I'm not knowing everything.
There is some confusion around various plugins, how Neutron, ML2, core plugin are related, and there is an ask for for a picture. We obviously cannot fix that during this meetup, but maybe we can add that to your presentation afterwards when the session is recorded.
So kind of like a flow diagram showing the options. Yeah, I could do something like that. Yeah.
Okay. Okay. Are we talking about VRP for HA capability?
For the HA function, we are talking about VRP. That's correct. So the two network nodes that are in this HA pair, let's go back to that slide, will then actually implement VRP to do this virtual IPs here.
Okay. Can we have multiple plugins active in the ML2 framework?
Can you have multiple plugins? So plugin is what the plugin is what we call in Neutron is the ML2 itself is a plugin in Neutron. So you cannot have multiple plugins active in Neutron. Now the ML2 plugin itself can have multiple different mechanism drivers below it. So what you would do is on a specific set of compute nodes, you use another mechanism driver than on another set of compute nodes. And then since you have the same type driver, or you could have the same type drivers, you'll get the same network IDs out of the type driver and use it on two different implementations using two different mechanism drivers, and then they should be able to speak to each other. That holds true for VLANs. Now, of course, with things like overlays with VXLAN and stuff like that, it gets more complicated because the actual implementation needs to also be able to talk to each other, and that's where we are not yet, a state that didn't reach yet, I would say.
Okay, so it looks like that's all the questions that we have. No other questions came in while you were answering those that people send in while you were presenting. Oh, there's actually one more question. If these slides will be available somewhere, and I'd suggest that we maybe add those slides to our YouTube channel once the recording is available. Would that be okay for you, Yves?
Absolutely.
Okay, so let's do that. Okay.
And especially because unfortunately the first 6 slides were not shown in the video now. That's bummer, but we'll post the slides and then you can.
We'll post the slides. They will be available on this channel here. All right, guys. So Yves, thank you again very much for the presentation. Thank you everybody for watching us live. So the recorded session as well as the slides will be available, and watch out for forthcoming sessions. We had actually 4 sessions this month, and Stephen and I will keep hosting sessions at the same pace, so expect at least 3 or 4 further sessions in September. And with that said, thank you again, Yves, and thank you everybody for watching, and see you next time.
See you next time.